Myself, Madhuri Modak, Assistant Professor in Mathematics, Department of Computer Science, Abhidayanandar Senior College. Discrete mathematics is very important for students of computer science. Now here we start with unit number 3, Techniques of Counting of Discrete Mathematics. Now the next point is the inclusion-exclusion principle. Now first see the inclusion-exclusion principle for two sets. For any two finite sets A and B, cardinality of A union B is equal to cardinality of A plus cardinality of B minus cardinality of A intersection B. That is, if A and B are any two finite sets, then number of elements in either A or B together is equal to number of elements in A plus number of elements in B minus number of elements in their intersection. Now, next is inclusion-exclusion principle for three sets. For any three finite sets A, B and C, cardinality of A union B union C is equal to cardinality of A plus cardinality of B plus cardinality of C minus cardinality of A intersection B minus cardinality of B intersection C minus cardinality of A intersection C plus cardinality of A intersection B intersection C. That means number of elements in A union B union C is equal to addition of cardinalities of individual sets minus intersection of all possible pairs and plus intersection of all the three sets together. So it is alternately plus, minus and again plus. Now these are the statements for two sets and three sets. Now there are some important formulae which we need while solving problems. If A and B are subsets of a finite set U and A dash or A bar is U minus A, denote the complement of A. That is, A dash or A bar contains the elements from set U which are not present in A. Then by De Morgan's law, complement of A union B is equal to complement of A intersection complement of B, which is same as U minus A union B. Now cardinality of A intersection B dash is equal to cardinality of A minus cardinality of A intersection B. Now what is actually cardinality of A intersection B? It is nothing, B dash, it is nothing but number of elements in A which are not in B, because here we are taking B complement. So how many elements are there which are in A but not in B? That is cardinality of A minus cardinality of A intersection B. Now next is cardinality of A intersection B intersection C dash. So it represents number of elements in A and B but not present in C. So it is cardinality of A intersection B minus cardinality of A intersection B intersection C. Similarly, what is cardinality of A intersection B dash intersection C dash? We represents number of elements in A but not present in B and C at a time. It is equal to cardinality of A minus cardinality of A intersection B minus cardinality of A intersection C plus cardinality of A intersection B intersection C. Now, similar to A intersection B dash, we can find cardinality of A intersection C dash or B intersection C dash in the same way. Now see first example. Among 100 students, 60 students got distinction in first year, 25 got distinction in second year and 15 got distinction in both years. How many students got distinction in at least 1 year? Now here first we have to define the sets. Now total students are 100. It means the universal set U contains 100 students because that is the set under consideration. Now 60 students got distinction in first year, 25 got distinction in second year and 15 got distinction in both the years. So we consider one set as set of students who got distinction in first year. Suppose that set is A. Let set B represent the set of students who got distinction in second year. Now we have given how many students got distinction in first year, that is 60. So what is given to us? Cardinality of A is 60. Similarly, 15 got distinction in both years and 25 got distinction in second year. So second year means that set is B. So cardinality of B is 25. And 15 got distinction in both years means 15 students got distinction in first year as well as in second year. So 15 students are present in A as well as in B. It means cardinality of A intersection B is given as 15. So whatever numbers are given in the problem, we have expressed them as cardinalities of A, B, A intersection B. Now we want how many students got distinction in at least 1 year. So in at least 1 year means either in first year or in second year. Now either or is nothing but the set A union B. So we need to find cardinality of A union B. Now as there are two sets and these three values are known to us and we want to find this cardinality, we use inclusion exclusion principle for two sets. Now, cardinality of A union B is cardinality of A plus cardinality of B minus cardinality of A intersection B. So, substituting these values, it is 60 plus 25 minus 15, which is 70. So, there are 70 students who got distinction in at least 1 year. So, the main thing is that you should define the sets properly and then decide whether you want cardinality of union, intersection, complement, etc. Now, second example. In a group of 200 students, 80 are taking physics class, 60 are taking chemistry class, and 30 are taking both classes. How many students are taking either a physics class or a chemistry class? How many students are taking neither class? Now again, the group under consideration is universal set. So U be the set of students in a group. Now that group contains 200 students. It means cardinality of U is given as 200. Now there are students who are taking physics and some students are taking chemistry class. So these are the two subjects. Accordingly, we define two sets, A as the set of students taking physics class and B as the set of students taking chemistry class. Now according to given information, as 80 are taking physics class, it is nothing but cardinality of A, that is 80. Similarly, 60 are taking chemistry class means B contains 60 students. So cardinality of B is 60. Then 30 are taking both classes. It means 30 are taking physics as well as chemistry class. So 30 are present in both A and B. It means in terms of set notation, A intersection B, that cardinality is 30. So these three cardinalities are given to us. Now, first question, how many students are taking either a physics class or a chemistry class? It means we want to find how many students are there either in A or in B. That is nothing but cardinality of A union B. So again, by inclusion exclusion principle, it is cardinality of A plus cardinality of B minus cardinality of A intersection B. Now these three values are known to us, so just substitute the values. So answer is 110. Now next is how many students are taking neither class. Neither class means how many students are there neither taking physics nor chemistry. It means we want to calculate the students which are neither present in set A nor present in B. Now not present in that set A, it means they are in universal set but not in that set A, not in that set B. Means we want to take their complement. So we calculate here number of students taking neither class as cardinality of A bar intersection B bar, which is cardinality of A complement intersection B complement. So it is by remark cardinality of U minus cardinality of A union B. It means from total number of students, we are subtracting number of students who have taken at least one class. So 200 minus 110, which is 90. So there are 90 students taking neither class. Now, one more example. How many integers from 1 to 1000 are divisible by 2 or 3 or 5? Second, 2 and 3 but not by 5. None of 2, 3 and 5. Now here we are considering integers from 1 to 1000. So u is in this case 1 to 1000. So cardinality of u is 1000. Now depending upon their properties, divisible by 2 or 3 or 5, we define three sets here. So A contains the elements x from U such that x is divisible by 2. So it contains the number from 1 to 1000 which are divisible by 2. Means 2, 4, 6, 8, 10 and so on up to 1000. Similarly, B is the set of all elements x in U such that x is divisible by 3. It means it contains 3, 6, 9, 12 and so on up to 3999. Now C is the set of all elements x in U such that x is divisible by 5. So it contains the elements 5, 10, 15 and so on up to 1000. Now we want to calculate number of integers from 1 to 1000 which are divisible by either 2 or 3 or 5. Means they are present either in A or in B or in C. So either are is nothing but union. So we need to calculate cardinality of A union B union C. But to use that inclusion exclusion principle, first we calculate cardinality of A, cardinality of B, cardinality of C. Then cardinality of A intersection B, B intersection C, A intersection C, and then cardinality of A intersection B intersection C, because all these values we require in inclusion exclusion principle. Now how to calculate cardinality of A? So A contains the integers from 1 to 1000 divisible by 2. So as we are considering the numbers from 1 to 1000 continuously, here to find cardinality of A, we divide 1000 by 2. So it is 500. It means 500 numbers are divisible by 2. Similarly, cardinality of B means number of integers divisible by 3. So it is 1000 divided by 3, which is actually 333.33. But we consider the greatest integer not exceeding this, means remove just the decimal part. So it is 333. Similarly, number of integers divisible by 5 is 1000 divided by 5, which is 200. Now, cardinality of A intersection B. Now, cardinality of A intersection B is number of integers from 1 to 1000 which are divisible by 2 and 3 at a time. Now, number is divisible by 2 and 3 if it is divisible by their LCM. So, to find that cardinality, we divide 1000 by LCM of 2 and 3, which is 6. So, it is 166.66. Again, removing the decimal part, it is 166. So 166 numbers are divisible by 2 and 3. Same way for B intersection C, as it contains number of integers divisible by 3 and 5. Here we take LCM of 3 and 5. So again it is 66. And same way A intersection C, that cardinality is 100. Now one more value, we calculate that cardinality of A intersection B intersection C. Now this is the set which contains the integers from 1 to 1000 which are divisible by 2 and 3 and 5. Means that integer must be divisible by 2, 3, 5 at a time. So we take LCM of 2, 3, 5 because the number is divisible by 2, 3 and 5 if it is divisible by their LCM. Now LCM means least common multiple of 2, 3, 5 is 30. So 1000 divided by 30 is 33.33, which is 33. Now we can apply inclusion exclusion principle. Number of integers from 1 to 1000 which are divisible by 2 or 3 or 5 is equal to cardinality of A union B union C, which is cardinality of A plus cardinality of B plus cardinality of C minus cardinality of A intersection B minus cardinality of B intersection C minus cardinality of A intersection C plus cardinality of A intersection B intersection C. So by substituting the values, we get 734. Now, next question is number of integers from 1 to 1000 which are divisible by 2 and 3 but not by 5. It means the set is, as it is divisible by 2 and 3, means the integers are present in set A as well as in B but not divisible by 5, means they are not present in C, means we take as C dash. So A and B but not in C means A intersection B intersection C dash. So by formula it is cardinality of A intersection B minus cardinality of A intersection B intersection C. Now these two values we have calculated already. So just substitute 166 minus 33 which is 133. Now number of integers from 1 to 1000 which are divisible by none of 2, 3 and 5. So neither divisible by 2 nor by 3 nor by 5 means not in A, not in B and not in C at a time. Means we want to take complement of all these sets. So A intersection, A dash intersection, B dash intersection, C dash, that is the required cardinality, which is cardinality of U minus cardinality of A union B union C, which is 1000 minus 734, which is equal to 266.